Hello, welcome everybody. Thank you for joining us for this earthquake brace and bolt training. My name is Mark Grissom. I'm the customer service manager for Earthquake Brace and Bolt. I'm here with Janelle Maffei. She's our executive director and also our chief mitigation officer, and she also is a structural engineer. As we move forward, I'm going to give you an overview of the program itself and what we look for and what we need from you. And then I'll turn it over to Janelle. She'll give you sort of more in depth of why we have the program, what it is that we're really trying to address, and some of the more technical aspects. So first, we are jointly managed by CEA and the Governor's Office of Emergency Services. We were created to offer retrofit incentives, and we were the first to promote a code compliant retrofit. We estimate there's more than 1 million homes in California that will fit the parameters of our program. In 2017, that will be our 4th year of the program. We provide up to $3,000 for a code compliant retrofit. Those retrofits have to be in accordance with Chapter A3. So Plan Set A and the LA City Standard Plan are construction documents that are in accordance with Chapter A3, so those both work. Plan Set A is for Northern California, and the LA City Standard is for Southern California. You can also do engineered solutions, but those engineered solutions must be in accordance with Chapter A3. We've grown every year to more cities and more zip codes. We started our pilot program with 2 cities and 4 zip codes. We've expanded in 2017 up to more than 30 cities and more than 140 zip codes. We hope to continue as funding allows to expand every year. Funding is through CEA. However, in 2016 and 2017, we were fortunate enough to receive $3 million from the state of California in addition to the funding that was provided by CEA. Now, our overall process for the program. Our timeline is 8 months. We provide 2 months to find a contractor and get a permit, and then 6 months to complete the work. The homeowners can obtain an extension if within that 2-month time frame they're not able to get a contractor or permit. We will give them more time to do that, but the overall time frame of 8 months still stays in place. So if somebody isn't able to get a permit within 2 months, and let's say they get an extension for an extra month, and within that time frame they do get it, they'll then only have 5 months to complete the work instead of 6. Once you have the permit and you can start the process, we need the pre-retrofit documentation uploaded to the website. We need the permit. The permit's language should say that it's in accordance with Chapter A3 of the CEBC, or that it's in accordance with Plan Set A or the LA City Standard Plan number 1. It can't say that it's done per engineered plans, but even that in the language should say that it's in accordance with Chapter A3. We also need before photos. Those before photos should be of the exterior of the house, 3 overall. We want 1 of the left side, 1 of the front, and 1 of the right side, and then 3 of the crawl space area showing the perimeter foundation. We'd prefer you to get a shot not too close up. We want to be able to get a good sense of what the crawl space area looks like, but make sure that we can see the continuous perimeter foundation in the shot. We don't want the shot too far back where you can't really tell where exactly that continuous perimeter foundation's at. Then once you obtain those and put those up there, we will review them, and if any corrections need to be made, we will reject that section and send it back with notes on what needs to be corrected. But assuming everything is good, then we will clear you to go ahead and complete the retrofit. Once the retrofit is completed, the post-retrofit documentation needs to be uploaded. So we need the signed building permit showing that it's been finalized, the invoice from the contractor broken down by materials, labor, and overhead and profit. So if that's not typically what you provide, that's what will be needed for our program. We also need after photos of the crawl space. We want to be able to see that the work that's been done. So if you have cripple walls, we want to be able to see that there's been bracing done. We'd like to see some bolting. If it can be seen on situations where it's just a stem wall situation where it's basically a bolt only, we definitely want to be able to see that. The homeowners will need to upload a payment authorization form and a W-9 form, IRS form W-9. Those need to be provided by the homeowner. The other documentation, the homeowner can request that the contractor upload it for them, but these two pieces of information need to be uploaded by the homeowner. The payment authorization determines where we send the check, whether we send it to the contractor or the homeowner. The W-9 needs to be in the homeowner's filled in with the homeowner's information, regardless of where the check is going to go. We also have a section of our website for you. You can go there. It's www.earthquakebracebolt.com. There is the contractor section, and within it, it goes over a lot of the information which we're going over today, but you can go back and review it if you need to. And it even has a video that goes over really what a code compliant Chapter A3 retrofit is, what we're looking for and what needs to be done. And now I will turn it over to Janelle.
Thank you. So the Earthquake Brace and Bolt Retrofit Program was created to mitigate or to fix a particular kind of seismic vulnerability or problem. And that is the problem with older homes that have crawl spaces under the first floor, and the houses are not properly anchored to their foundation, and crawl spaces are not properly braced with plywood. You'll find the cripple wall house or the stem wall house comes in a variety of different shapes and sizes. You will find that they are very, very common in pre-1940 houses. The program does allow a house if it's pre-1979 and has one of the qualifying conditions. The classic cripple wall house will have 5 or 6 steps up to that first floor, access into a crawl space, and if you look around at that crawl space, you'll see short stud walls that are referred to as cripple walls in the construction industry. Cripple wall failure can be very destructive. This is an example of a house that was damaged in the 2014 magnitude 6 earthquake in Napa. You can see on the upper right-hand picture is a cripple wall. So those are the short studs that surround the crawl space that has toppled over off of the foundation. This kind of damage can be both dangerous and costly. This is an example of the dangerous cripple wall damage. In this case, the porch fell down, blocking the front door. And on the lower right, you'll see that the gas line could easily have been severed. And of course, a fire combined with blocked exits could have been catastrophic. Cripple wall damage can also be very costly. This house in Napa was damaged during the earthquake and not yet reoccupied 2.5 years after the earthquake. This damage is commonly found in the older Victorian homes, particularly those tall homes. This is a 2-story home in the Napa earthquake. It leaned over during the earthquake and then the next day came down off of its cripple walls. Cripple wall damage is particularly prone to houses that are not well maintained. Obviously, houses that don't have wood in good condition or concrete in good condition are not as capable of resisting earthquake forces as houses that are properly maintained. Cripple wall retrofits work. This is an example of two almost identical houses after the Napa earthquake. The house on the left, the house I showed previously, was severely damaged, red tagged, had actually come down off of its foundation. You can see it's considerably lower than the house on the right. Blue house on the right was still functioning and operational the day of the earthquake. The owner came down the stairs, obviously had some damage, quite shaken up, but they were able to shelter in place to stay in their community. The owner on the left, not able to reoccupy for 2.5 years, all the while living somewhere else and still paying for that mortgage. So very costly damage. Seismic retrofits have been encouraged in the state of California for quite some time, but they are done under a voluntary retrofit basis. So essentially there is no mandatory retrofit required of the owner. They are volunteering to retrofit their own house. And so often on permits, we would see the term voluntary retrofit. Now this allowed the building official to allow just about anything as long as the work did not make the house unsafe. Unfortunately, retrofits were often incomplete. They did not have to be completed to any kind of standard or code, and often were not as effective. If they're not completed or done to a standard, often they're not done in a manner that can really afford the house any protection from earthquakes. So as mentioned before, earthquake brace and bolt is requiring a code compliant retrofit, and that code is Chapter A3. State of California adopted Chapter A3 in January of 2011, and it is currently in the California Existing Building Code. Chapter A3 is prescriptive provisions for seismic strengthening of cripple walls and sill plate anchorage of light wood-framed residential buildings. So once again, it is intended for that particular vulnerability when a house has cripple walls and doesn't have adequate sill plate anchorage. There are plan sets that are available that are in compliance with Chapter A3 that are used throughout California. In Northern California, Plan Set A is typically used. In Southern California, the LA Standard Plan Set Number 1 is used, and these are considered construction documents in accordance with Chapter A3. It's important to note that these are prescriptive plans that can be utilized by contractors or homeowners as owner-builders without an engineered solution, provided the house qualifies. And the house, in order to qualify, must have cripple walls that are less than 4 feet tall and doesn't have large openings that preclude introducing the amount of plywood or bolts that are required. If you don't meet the requirements of Chapter A3 for a prescriptive plan, you can provide an engineered retrofit, and that retrofit, once again, needs to be in accordance with Chapter A3. So why the 4 foot or less cripple wall requirement? So 4 feet really is the cutoff for when you might need a hold down on the walls that you're introducing under the crawl space. So essentially these prescriptive plans are pre-engineered solutions, and the engineering solution in this case does not require a hold down. Hold down solutions at this time require an engineered solution. A question that we often get is, can I use a plan set on a house with an attached garage? So the answer is, if the crawl space area to be retrofitted meets the requirement of a plan set or Chapter A3, and the building official allows it, then it will be allowed in the earthquake brace and bolt program. It's important to check with the building official because oftentimes with a garage that's tucked under the house, you might have walls that are greater than 4 feet, or you might not have sufficient length of cripple wall available to put in the required length of plywood. So it is important that you check with the building official when you have an attached garage. As an example, garage retrofits will typically require additional types of retrofit schemes. They often have walls that are taller than 4 feet, so once again would not be prescriptive. And they often require prefabricated seismic resisting elements. such as these either plywood or steel walls that go either side of the garage doors, or steel frames that frame around the garage door. Those, of course, require an engineered solution. The Chapter A3 prescriptive house is typically a pretty simple house, 5-6 steps up to that first floor. And of course, you can see on this picture the access to the crawl space under the house on the right-hand side. Continuous perimeter foundation, crawl space, walls that do not exceed 4 feet, and no significant openings underneath that floor. Another type of prescriptive house doesn't necessarily have a cripple wall, but will still require new anchorage, either anchor bolts or foundation plates. So that house we consider a stem wall house. That's where the wood floor sits directly on the concrete foundation. And we have pictures of that from under the house a little bit further along. A3 retrofit requirements are pretty straightforward. Maximum stories 3. Anchor bolts required are 1/2 or 5/8 inch diameter. Foundation anchors that come in from the side can be proprietary or fabricated. The cripple wall sheathing plywood or OSB. Framing clips, once again, proprietary or fabricated. And all of them do require a new continuous concrete footing. And in all cities in California so far, building departments are allowing you to do those new footings prescriptively. Comparisons of A3 with the plan sets will show you that they're very similar. Plan set A is a little bit more conservative. Plan set A has a cutoff of 2 stories, only allows plywood, and does not include a new continuous concrete footing detail. Once again, when you're using Plan set A, building departments are typically accepting a prescriptive new footing detail, and you can utilize the ones from Chapter A3 or the LA Standard Plan. In all cases, retrofit plans are required for the permit documents. These plans are very standard for construction documents. You're providing a plan with dimensions. You're indicating the location of the new plywood, the length of the plywood, size and spacing of the nails, indicating the number of anchors, and then showing any things like chimneys or furnaces and things that might be in the way, and how you're installing the plywood kind of around those elements. There are examples in Plan Set A and in the LA Standard Plan Set. Additionally, on these plans, you'll be cutting sections that correspond to the typical details that are in Chapter A3 or the standard plan sets to indicate what type of work you're doing along a particular length of footing. The LA Standard Plan Set has a very simple table in it. This is an example of perhaps a 2-story house. It gives you an indication of the length of plywood required under the house on each wall, the sill plate anchorage, size and spacing, framing anchors at the top of the cripple wall, and joist blocking that might be required. Plan Set A is a little bit more complicated in that you will have different table lines for 1 stories and 2 stories. Houses, you calculate the total floor area in square footage. You calculate or assess whether it is heavy or light construction. For example, slate or clay tile roofs are heavy, stucco is heavy construction. Once you identify those elements, you once again are looking for the length of plywood bracing, the size and spacing of mud sill anchorage, and the size and spacing of your floor to cripple wall connection at the top of the wall. Chapter A3, similar to the LA Standard Plan Set, number of stories, sill plate connection, amount of bracing for each wall. Prescriptive details are in A3 and both plan sets. They show you the details at the top of the wall, anchorage at the base of the wall, and information about nailing the plywood or OSB to the cripple walls. It's important to note that Chapter A3 does require that wood that is part of the retrofit shall be in sound condition and free from defects such as fungus and insect infestation. It's very important that if you have plumbing or electrical or any other subsequent construction that has damaged the wood, that you replace that as well. Additionally, if you have concrete that is in bad condition, that will need to be replaced. Chapter A3 does require that if damaged, materials need to be replaced with new materials with the same net dimension as the original. So if you have older houses with 2-inch by 4-inch studs, then you'll need to replace with 2-inch by 4-inch new materials. The condition of the concrete foundation is very important. First and foremost, the concrete needs to be in good condition. And if you have stone, brick, or unreinforced masonry, then that foundation is not appropriate for a prescriptive solution. You will need to have an engineer look if you want to add a foundation to a house that does not have an existing concrete foundation in good condition. Chapter A3 does allow for a new footing to be done in a prescriptive manner, so once again by a contractor or homeowner without an engineer design, and there is a detail in Chapter A3. A local building official may require a soils report. We have not found local building officials who are requiring soils reports. We're finding that they are all allowing the introduction of new footings that are done to prescriptive standards. LA Building Department Standard Plan Set also has a new footing detail, and once again, either one of these can be used with Plan Set A. For the dwelling anchored to the foundation, you install anchor bolts if space permits. So if you can get in there with a roto hammer and drill down from the top, then an anchor bolt would be an appropriate solution. If the cribble wall is short, or you have a stem wall condition where the floor sits directly on the mud sill, which is directly on the foundation, then a proprietary or constructed foundation plate would be installed from the side. Note that those proprietary or foundation plate anchors are screwed into the mud sill and bolted into the concrete foundation. For basement conditions, these are the same as a stem wall condition. So essentially when the floor sits directly on the top of a basement wall, you go in with a proprietary anchor or a foundation plate, and once again screwed into the mud sill and bolted into the concrete. Now, it's very likely in older homes that you find mud sills that are wider than the cribble wall studs. In order to create a flat surface to apply the plywood, you will be required to put in new blocking. It's important that anchor bolts are installed through that blocking. Also, they need to be installed with approved washers that are indicated on Chapter A3 and plan sets. Now, the intent of the anchor bolt is that it's holding the wood portion of the house onto the concrete. And so you need a good length of wood at the end of each mud sill so that that anchor bolt is not ripped out of the mud sill. That's called the end distance, and it is specified as between 9 to 12 inches from the end. It's important that you maintain this. Also important that you have at least 2 anchor bolts per stick of mud sill. So end distance and a minimum of 2 and spacing for anchor bolts is very important. Also positioning as close to the center as possible. It's not recommended that you rely on old anchor bolts. This is the kind of degradation of anchor bolts that you might find. If a building official will allow it, and you do have a few new anchor bolts, they're shiny and new and are clearly installed with the appropriate plate washers, the building official allows it, that might be appropriate, but we generally do not recommend that you rely on old anchor bolts. It's important to note that the new foundation plates are a particular thickness with a minimum of 3 screws into the mud sill and 2 anchors into the concrete. It's important that if you're going to fabricate these yourselves or use a proprietary foundation plate, that you make sure that they do meet the qualifications of the document that you're using. Here's a picture under the house of that stem wall condition. So once again, the floor sitting directly on the concrete foundation. These are foundation plates that have been anchored once again with screws into the mud sill and bolts into the concrete foundation. Here's a close-up. There's that foundation plate on the right, and then there is an important framing clip that connects the mud sill to either a rim joist or to blocking. So that's either at the top of a cripple wall, or in this case, in a stem wall condition, from mud sill to floor. Cripple wall bracing is essentially the installation of a shear wall underneath the house. So this shear wall is every bit as important as a shear wall that you would be installing anywhere else in a house. It's highly recommended that you install the sheeting on the inside face of the cripple wall. In the few conditions we've seen installed on the outside, you run into issues with the fact that you are disturbing the moisture barrier of the house. In many cases, you will be touching older, perhaps expensive, difficult to replace materials such as redwood siding, difficult to take off. There's added cost to both you and to the homeowner. We found in most conditions it is perfectly acceptable and easy to install on the inside of the crawl space. Very important as well that you're anchoring that top plate to the floor framing above. New plywood sheathing that's installed on the inside is adding a shear wall, as I mentioned. You can see on the left, you can see the studs. Those are the cripple wall studs. You can see the existing finishes on the outside. And then, of course, this bracing that went in originally, which was typically just to keep the house plumb as it was being constructed. I mentioned before, new blocking might be required. Mud sills are often wider than the cripple walls, and it's required to create a flush face for the sheeting. Now, we are creating shear walls, and properly placed nails are essential to good performance in shear walls. So the size and spacing needs to be as required by the code or plan set. No overdriven nails. Make sure that the person who's using the nail gun is experienced, that it's set correctly. Perhaps you do some tests. No overdriven nails, no shiners. Obviously, you want to maintain the appropriate edge distance on nails. The shear wall is only as good as the proper nailing that's been used to attach it to the foundation. And then finally, as I mentioned before, framing clips at the top of the cripple wall or from the mud sill. So this is the element that's connecting the floor to the cripple wall or to the mud sill. Plan Set A does allow a Simpson H10 instead of a framing clip. That's only Plan Set A. That is not allowed by Chapter A3 or the LA Standard Plan Set. That H10 is in lieu of a framing clip and is not intended to replace any other element. You still need foundation plates, and if you have cripple walls, you still need plywood. The framing clip details are shown on Plan Set A, the LA Standard Plan Set, and in Chapter A3. Vent holes are required in each stud bay. There are 2 required unless you have a cripple wall height of 18 inches or less. It's important that you do put mesh to keep critters out of the bays, and important that you make sure that the dimension and location of those holes is as described in the permit documents. I'm going to show a couple of pictures that are not seismic retrofit. It's important to note that this retrofit is done at the perimeter bearing walls. There is no work required at the interior of the crawl space. So if you as a contractor are under the house and you see interior posts and beams that are in bad condition, perhaps a post that's not centered correctly on its pier, maybe some degradation of the materials in the crawl space, that would be a separate contract between you and the homeowner. It is not part of the retrofit. Nothing is to be done at the interior that would be considered a retrofit. Certainly no hold downs at the interior of the crawl space are appropriate. They're not appropriate at the interior and certainly not in a prescriptive plan set. So once again, the work is only along the perimeter, but neither of these elements can be found in Chapter A3 or on the plan sets. That plate doesn't have sufficient screws into the mud sill, is likely not the sufficient thickness. And there are no angles indicated in any of those documents. We do occasionally see these angles specified by engineers, but they would not be appropriate for a prescriptive retrofit. And once again, you will not find them in the plan sets. Here's an example of a before picture. You can see that it's got a nice picture with showing the floor, showing 2 of the walls. And of course, the after picture from the same angle is appropriate. It shows us that the work continues from the top of the cripple wall down to the foundation. We can see the foundation, we can see the OSB, we can see the nailing, we see the vent holes, and very important, we see those framing clips at the top of the wall. For the short crawl space or the stem wall condition, once again, a before picture, in this case showing 2 walls, and a nice clean picture showing us the plywood, nailing, vent holes, the foundation plates, and that there's a couple of foundation plates and that the work continues down the wall. Now we recognize that we've shown a very simplistic overview of the program, and that the houses that you will confront in the Earthquake Brace and Bolt program are of various sizes, shapes, configurations, and in various states of maintenance. We appreciate the hard work that you do, that you will have questions. We encourage you to make use of our customer service manager. We also encourage you to work with your local building departments, make sure you understand their requirements, and as their word is the final word on what's accepted in the program. We thank you very much for participating in the program and wish you the best of luck.
Again, thank you for joining us. You see my slide there. You can get in touch with me if you have any questions. We also have a call center where you can call in if you have a general question. You can also refer any homeowners to that number. It's 877-232-4300. So if you have any homeowners that have general questions, that's where they should be going. My number and information here is basically for you if you have any questions. But as I said, you're free to use the 877 number also. They should have any information that you would require. Thanks again for joining us, and hopefully we'll be working together. Thanks.